Okay, let us now take a look at one problem in summative exercise, question number 10. Okay, let's go to the question first and try to understand what the question is asking. Now, in the diagram on the right, AOB is a semicircle. Take a look at this diagram. So where is AOB? AOB is here. So this is a semicircle, and you are told that this is a semicircle with center D. Okay. And AEB is an arc of a circle with center C. Coordinate of center is given 7, 7. So where is AEB? AEB is here. So this is an arc with center C. Coordinate is given 7, 7. The equation of line AB is x over 6 plus y over 8 equal to 1. So you are given the equation of the straight line joining point A to B. That equation is given. You're asked to calculate what is the area of triangle ABC. So where is this triangle ABC? ABC is here. ABC, this triangle. You're asked to find what is the area of this triangle. Okay. So if you remember the formula for area of triangle, so we can find area using half AB sine C. So half AB will be the two sides. We have AC and BC. And then we need to find what is the angle here. From there, we can find what is the area of triangle ABC. So let's try part A. Okay. So area of triangle ABC is equal to half AB sine C. So what is A here? A will be AC times by BC times by sine of angle ACB. Okay. So in order to find AC, we're going to use the coordinate of the point A and C. So we need to find what is the coordinate of point A. So we are going to use this equation. We know that at point A, x value will be 0. So when you put x inside here, you can get what is the value of y at point A. And similarly at point B, y value, y coordinate is 0. If we put y inside here, we can find what is the x coordinate. So like that, we can find the coordinates of point A and B. So here we say at point A, x is equal to 0. Therefore, y is equal to 8. So you can get from this equation directly here. When you put x is 0, bring the x 8 to the other side becomes multiplier. 1 times 8 will give you 8. Similarly, at point B, y is equal to 0. And therefore, x will be equal to 6. So in other words, we found the coordinate of point A and B. So coordinate of point A will be x0, y will be 8. Coordinate of point B will be x is 0, y will be, x will be 6, y will be 0. And so this one will be 6, 0. Okay, this will be 6, 0. So in order to find AC, in order to find AC, so we are going to make use of coordinate point A and coordinate point C. Okay, so if we draw a dotted line there, so you'll notice I'll use red color so you can see more clearly. Now what I'm going to do is I'm going to draw a horizontal line passing through point C, okay, that touches the vertical axis. So here I draw a vertical line, and then here we got horizontal line. So this angle must be 90 degree. Okay, and the distance here, the horizontal distance will be distance from this point, and this point to this point. Horizontal distance will be, because this is 7 unit. Okay, so this distance will be given by 7. And the vertical distance from here to here, because this point is in parallel with this point. Okay, therefore, at this point, you have coordinate 0, 7. So this is 8, this is 7. 8 minus 7 will give you 1. So this height will be 1. Okay. So we have a small triangle there where the distances are given like that. Maybe I can draw the small triangle there so you can see more clearly. Okay, imagine that this is point C, this is point A. And this vertical distance, this is right angle, vertical distance is 1 unit, this is 7 unit. So from there we can find AC. Okay, so we have AC is equal to square root of 1 square plus 7 square. So this will give you square root of 50. Okay, so we leave it as a square root and leave it as a set, don't modify this. So the area of triangle ABC will be equal to half times AC. AC will be square root of 50. What about BC? Okay, because AC is equal to BC because both are actually the radius of the arc AEB. So this is also equal to square root of 50. In other words, BC is also square root of 50 multiplied by sine of angle ACB. So we try to simplify this. Half times square root of 50 multiplied square root of 50 will give you 50 times sine of angle ACB. And so if you work it out, you'll get 25 sine of angle ACB. Okay, so now we need to find what is angle ACB. So in order to find angle ACB, we are going to use cosine equation because we know the length of AC, we know the length of CB, and we can find length of AD. Because we know that the distance from O to A is 8 unit. Okay, so this is 8 unit. And then the horizontal distance is 6 units. So we're going to use Pythagoras theorem to find AB. So AB square is equal to 8 square plus 6 square. So AB is equal to square root of 8 square plus 6 square. This will give you 10. Okay. Therefore, cos of angle ACB is equal to R plus, not to say R, the cos of the angle will be given by AC square plus BC square minus AB square. So AC square will be square root of 50 square, okay, plus square root of 50 square. So because your AB is same as BC, here AC is equal to BC. So here also you can write that this is also equal to BC. Minus AB square will be 10 square divided by 2 square root of 50 multiplied by square root of 50. Okay, so this will be equal to, if you work it out, you will get square root of 50 square will be 50 plus 50 minus 100 divided by 2 times 50. So you'll notice that at the numerator you have 50 plus 50 will give you 100. 100 minus 100 will give you 0. So this will be actually equal to 0. So if you find this angle ACB, if you take cos inverse of 0 will be equal to 90 degree. Cosine at the bottom equal to, okay. So now we can find what is the area of triangle ABC. BC is equal to 25 sine of 90 degree. So sine of 90 we know is equal to 1. So this will be 25 unit square. Okay, so that is the area of triangle ABC. So that is answer for part 1. Okay. Now in part 2, you asked to find what is the angle ACB in degree. So we already found it earlier, angle ACB. So part B, angle ACB equal to 90 degree. In part C, you are asked to find what is the area of the shaded region. Okay, what is the area of the shaded region? Let's take a look. Where is the shaded region? Now you'll notice that the shaded region is inside here. So in order to find the shaded region, so if you take the area of the sector AOB, the area of the sector, and then you minus the area of the segment here, then you'll get the area of the shaded region. And area of the segment is given by area of sector AEB, this sector, minus the area of the triangle. Okay, so there are two steps. One step is to find what is the area of the segment, largest segment, and then, largest sector, and then you must minus the area of the segment here. So let's try part C. In part C, area of shaded region equal area of sector AOB, AOB, area of sector AOB minus area of segment. Okay, we have space, continue there. Area of segment AEB, segment AEB, which is given by area of sector AOB minus area of sector AEB minus area of triangle ACB or ABC. Okay, so I'll just repeat this part here. How to find the area of the shaded region is given by area of sector AOB, which is sector AOB, area of the sector minus the area of the segment. And area of segment itself is given by area of sector AEB minus the area of triangle ABC. Okay, so that is what we are doing here. Okay, so there are two parts here. And area of sector ABC or area of sector is given by half r square theta. So when you look at sector AOB, half r square, what is the r for this value? R will be given by half the distance from A to B. So what is distance AB? Distance AB, we just calculated that to be 10 units. So half of 10 will be 5. So that will be the radius. So this will be half r square theta is equal to half times 5 square. Okay, times angle, because this is a semicircle, for the sector AOB is a semicircle, the angle will be pi, pi radian, minus area of sector AEB will be half r square. R square will be square root of 50 square times by angle AEB. Yeah? AEB, sorry, angle ACB. Yeah? We already found the angle ACB earlier. So the angle is pi over 2, 90 degrees pi over 2. Minus area of triangle, just calculated just now, it will be 25. So if you work it out, you'll get half times 25 times pi minus, inside this bracket, you'll have half times 50 times pi over 2 minus 25. Okay. So you notice that here we can cancel this 2 and 50. Divide by 2 will give you 1. Divide by 2 will give you 25. So when you remove the bracket, okay, when you remove the bracket, you'll notice that you'll get 1 over 2 times 25 times pi minus 1 over 2 also 25 times pi. And then minus, this minus you bring inside, minus will give you positive, will give you plus 25. Okay, so you notice that this part is exactly same as this part. So these two will cancel off. So when they cancel off, you'll get, finally you'll get this as 25 units. Okay, so that will be the area of the shaded region. Area of shaded region. Okay, let's go through one more time very quickly just to revise this. So you asked to find in the first part, what is the area of triangle ABC? Yeah, so here we are using the formula half AB sine of the angle. So AC and BC will be the radius. So we can find AC from this small triangle here because we know the horizontal distance and vertical distance. And AC will be equal to BC. Okay, AC will be equal to BC. So you'll get answer square root of 50. So from here we can get the area. After we find the angle, which is 90 degree, we can find what is the area of the triangle. And then the area of shaded region is given by area of sector AOB minus area of segment AEB. Okay, so when you work it out, you'll get 25 units square. Okay, so try this question. It looks a bit complicated, but you need to understand what they're asking and then try to analyze step by step how to do this. Okay, so I'll stop the recording here.